Good morning, everyone. Welcome to the frequency filter tutorial video. I am going to send this out a little bit early because some of you have been struggling with your homework saying that you're unable to do it without some type of tutorial. So I'm going to send this out just a little bit early. I know it's Sunday, but I just got a group of people email me last night saying that they were having trouble. So I wanted to get this out before at least the assignment is due. Um, so let's dive right into it. So we're talking about high frequency filters. Typically, the software of a high frequency filter on an EEG system is going to be 15 hertz high frequency filter, 30 hertz high frequency filter, and 70 hertz high frequency filter. Those are going to be your most common frequency filters. Um, some weird software you may see different. You may see 75 high frequency filters, but let's focus on the three that you will see in the majority of the software. So let's start with a high frequency filter of 15. Now, the main thing that you need to really understand for the high frequency filters is the number that they give that they're saying, okay, so this is a high frequency filter of 15 hertz. What they're saying is we are going to diminish the amplitude of the EEG by 30% at 15 hertz. Okay, so let me say that again. So if you have a high frequency filter of 15 hertz, that means the amplitude, the frequency down here, the amplitude is going to be attenuated, or it's going to, I guess you could say, shrink, or it's going to lower in amplitude at 30% at 15 hertz. Okay, so the first point that you want to draw, it's a very easy point that you want to draw on a graph of a high frequency filter, is the frequency that they're talking about. So let's pretend that this line isn't here and we just have this graph. Here's your amplitude, here's your frequency. Now whenever I say diminish or attenuate the amplitude, I mean, if you see a wave without any filter, that's going to be 100% of the wave, no matter how tall or how short the wave is. That's 100% of what the wave is. Now, if you add a frequency filter, it is going to attenuate the amplitude, and it's not going to be 100%. It's going to be, 70% in particular, in this case, a high frequency filter of 15. It's going to attenuate 30% of that wave of a 15 hertz frequency. Okay, so if you have 15 hertz in 1 second and you put in a 15 hertz high frequency filter, the amplitude of that wave is going to attenuate to 70. So you'll only see 70% of the amplitude of 15 hertz in a 15 hertz frequency filter. That's a lot of things to kind of understand. But once you get that concept, replay this over and over, listen to that again and again. Once you get that understanding, it will greatly help you in this assignment. So let's say this wave isn't here again. I'm going to draw my point. I'm going to come and I'm going to say, okay, this is 15 hertz. Where is 15 hertz here? Okay, in this case, I had to draw it. Okay, so 15 is right here. Now, where is 30%? Because I know that the high frequency filter of 15 hertz attenuates the amplitude at 30% at 15. Okay, so I come to here. Here's 30% of 100. And you can draw a dotted line this way. That's what you'll see on the graphs in the book. And then you can draw a dotted line on the 15 hertz. And then wherever those intersect, that's where your first point is going to be. So you're going to make that point right there. Okay. Now, the second point is going to be for 15 hertz, it's going to be when you double the hertz, you are going to see 70% degradation or attenuation in the amplitude. So what is 30% of 15, or sorry, what is double the amount of 15? Did I say 30% of 15? No. So let me restate that again. If you have a 15 hertz high frequency filter, whatever is double, the number that is double that times 2, in this case, 15 times 2 is 30, that will be where you find 70% amplitude degradation. Okay? So I say, here's my first point at 15. I double that, that's 30. I go here, I find 30. I draw a dotted line up here, and then I go to 70% degradation or 30% of showing it, and then I draw a line here, okay? And I draw it wherever it connects, that's where it's at. Don't get confused whenever I say 70% attenuation. I'm basically saying you can see 30% of it. So this is like saying I can see 70% of it when there's 30% attenuation, okay? So I can see 30% of this wave or 70% attenuation. I draw my line here. Then I connect those dots kind of in a curvy pattern. And then I can just draw the pattern, draw the amplitude to kind of die off. There's no hard set rule on how you have to draw it to die off. This student in particular in my last class drew 100% at 7.5. That is true. You'll see 100% of the amplitude at half of the frequency. But right now I want you to focus on these two dots right here. And then you kind of just make it curve to look something like this. Okay, so in this one, some software, like I said, it's a little confusing sometimes. Some software you'll see a 20% amplitude attenuation. So in this example, let's say this is a 15 hertz. Well, it is a 15 hertz high frequency filter because it's pointed right here. At 80% of 15 is where the line has been drawn, and then it kind of just dies out here. You see how that kind of curves there? Okay, clear as mud. Replay it over and over and you'll get it. You'll understand it. So high frequency filter of 35 hertz. Okay, so what is the first thing we want to do? We want to find 35 on the frequency axis here. In this case, you had to draw it. And so 35 is right here. I draw a dotted line straight up, okay? And at 35 hertz frequency filter, what am I going to see? I'm going to see 30% attenuation of the amplitude, or I'm going to only see 70% of the amplitude. And I draw a dotted line all the way to the right. Wherever these points connect, that's where my first dot is. Then what is step number 2? I multiply 35 by 2 to give me where I'm going to see a 30% amplitude or 70% attenuation. And 35 times 2 is 70. So I come up to where about 70 would be on here. I draw a straight line going straight up, and then I go to my 30% amplitude or 70% attenuation. I draw a dotted line going all the way to the right. Wherever those points intersect, I draw my second dot. Then I connect those dots and kind of make the graph curve a little bit like this one. So this is 35. Here is the dot of attenuation at 35, and it's not mentioned, it's not shown here, but 35 would be right here. They drew a dotted line all the way up, connect those dots at 70. So at 70, you would see an attenuation of 70%, and you just draw that line there and make it look like a graph. There, like I said, you can do the 7 point. So at 50, it would 35 divided by 2, 15, 17.5. So at 17.5, you make the 100% amplitude here, and you could draw the rest of that curve. But like I said, I want you to focus on these two dots. Now it's going to be the same way for 70 hertz filter. You're going to, and this is going to be the most common filter that you use if you have to use a filter. We don't always want to use a filter, but sometimes we have to. So when I look at this example, I say, okay, high frequency filter of 70 hertz. First thing I do, go to my frequency axis, 70 hertz, boom, find that 70 hertz line. I draw a dotted line all the way up to the top. Then I go 30% degradation or attenuation of amplitude is 70%. I draw my dotted line all the way to the right here. Wherever those intersect, I draw my first point. Now, this one's going to be tricky because it goes off the graph. So you have to think outside the box and make your 140 point, because 70 times 2 is 140. That's where you're going to see 70% attenuation of the amplitude, or you're going to see 30% of the amplitude. And you're going to draw it out here somewhere. So that's 140, and then you just pretend that that's part of the graph. You draw your point here. You're going to make that connection there, and then you're going to continue. I don't want you to leave this out. I want you to continue to show that the frequency filter continues. It's going to be the same way with the high frequency filter, or sorry, low frequency filter. First thing I'm going to do, 5 hertz frequency, and that's the one key to remember. High frequency filter goes from top left to bottom right. Here, high frequency filter top left to bottom right. With the low frequency filter, it's going to go from the bottom left, it's going to go from the top right to bottom left. That's the slope that you're going to see. So 2 keys, low frequency filter, I know it's going to be top right to bottom left, 5 hertz. I go to the 5 hertz frequency axis here. I find it, draw my straight line up. Then I find 30% amplitude, which is the 70% amplitude here. I draw a line there. There's going to be my first little point. I know it's a low frequency filter, so it's going to be, like I said, top right to bottom left. So I move to the left. I find what half of 5 is going to be. It's going to be 2.5. I imagine 2.5 is this tick right here. I go up and I find my 30% dot. I make my dot here. I connect it just like the high frequency filter, and then I continue with my curve. And it's going to be the same for your 1 hertz frequency filter. You're going to find 1 hertz, draw it up 70%, and it's going to be the same for your 0.3. I know it's a little bit hard to understand, but I think you will be able to understand it the more and more you listen to this video. I know I go through it a little bit quick, but it's actually an easy concept to understand, and I don't want to spend too much of your time going over it. Just replay this video over and over and look at your book. They have some good stuff on high frequency filter. And like always, if you want to meet with me at some time, I am open to do that. It's actually my job to do that. So please meet with me. Okay. Everyone, that is high frequency filters and low frequency filters response curves. I will see you in the next session.